Hello, everyone, and welcome back to the broadcast. We are going to be continuing our game dev project today. Found some solutions to some problems from last time. We'll see how well it works. Oh man, somebody messed up the cameras there. The little pillow has been pulled. I use a little draft excluder there. But they have hauled it out of the way. Wonder what mayhem caused that. Checking in with them, we have Sky up in the tree, Mason on the bed, Sherbet right up next to the TV screen. Sammy is lurking overwatching their Molly there. Oh, but we are... Okay, so we have a test file here, which let me show that a moment. Folder. Get this loaded here. This is the test file. So last time what we were trying to do... Hey there, Key. Welcome. Last time what we were trying to do was make a file that constituted unit vectors aiming to the center. Because we wanted to avoid having to constantly recalculate that unnecessarily. It's not the biggest deal to run that calculation over and over, and this does eat like several hundred kilobytes, just short of 4/5 of a meg kind of territory, to have this thing loaded, but it means that we can just reference the pixels and say if in relation you are kind of hard to see in the upper right corner, you move down and left. The other thing that this does is act as kind of a proof of concept, or at least a basis for us to move on to the step that I want to get started on today, ideally finish. Ack cough. Get a fresh beverage here. Rummage. How you doing, Sammy? Huh? Come here. Yes, you get back scratches. Come on. Yeah? Sammy's being very particular. Okay, let's hop on back here. So this is the mess that we did to get this working, where it just kind of brute force creates it. We're going to change this so that there is, as part of the loading, a check to see if this already exists. And if it already exists, we won't make it again. Is this breakable? Yes. We can incorporate stuff later if it becomes an issue. My OBS screen suddenly got needlessly big. There we go. It conceals the audio if it does that. And then I can't notice when it breaks. Not if it breaks, when it breaks. Amber. Yes, I acknowledge you. I do. Yes, come sit with me. Okay, so what we'll do is we'll move this stuff to an object that generates it, if it needs to. It will also be the location to go get it. Or at least to query it. So we're going to make another service for that. It's not collision. I'm operating around cat right now. Let's see, how do we want to do this? This would run at startup, and we need to find a way to identify them. It's not map generation. Molly, come on. No, it's a box. It's mine. Come on. You're gonna fall. Come here. You can play down there. Hey, Laura. I tried to pull it away and she kept scooting forward to stay inside it. Yes, I know. I moved around Ember. She has returned. I have to make sure I lavish attention on her because when I'm playing some of the games I'm playing recently, like Helldivers and War Thunder and the like, shoulder lamprey isn't conducive to gameplay. You can't have that either, Molly. Yeah, I'm just killing all the fun today. Yeah, quit it. Well, that would be the rule, but Molly doesn't fit on much of what she tries to sit on. Molly is less of a liquid cat and more of a pudding cat. She does have volume, but there's none of that, like, fluid grace involved. Okay. What are we going to call this? We're just going to call it meta generation because it is it makes particular things about particular things. So these aren't textures. These are going to be special things. The catalog will have to load them in a particular fashion. And we need to be able to find all of them. So I think we're going to be able to do like a get by category. So part of the reason that we're going to need to be able to load and generate these is to... let's see. Laura says, I'm on the last part of my core loop. When this is done, I will have a playable game. It'll not be pretty or fun or complete, but it will be playable. That is a big step, though. Reaching, like, core loop done lets you iterate on the actual game more easily. Because now it's not theory, it's actual, like, does this work? Like, is the game properly game? As opposed to, is the program functioning? You'll still get that latter one, but being able to do the former one is a big deal. So how do we want to place this thing? So we need to be able to extract these. We need to be able to find, well, not EXRs. We will need to find EXRs. Making a distributable program, especially since you're doing most of your work in Godot, pretty much all the work in Godot, is super easy, lore. Let's see here. I remember where we put that. Bennett apparently on a stream streak. Well, there is a location that you go to within the config lore to actually cause exports to happen, and that will make the kind of distributable package. I don't know where that is at the moment. I will eventually have to find it too. With the added difficulty is I need to find a way to also package, but like the data folders need to be exposed. Whether that's part of the installation or something like that, I don't know. Hey there, Lunar. Did I add the Blockbreaker Castle Siege boss fight yet? That could be a neat one. You have a bunch of fixed position enemies. Let's see. So we're laying the groundwork here. First, we want to have this generated if it's not present. So right now it's text.exr. There's going to be something else that it is. So this is a known commodity. We also need a way to get the maps loaded such that either when the map is started, which is risky because it's slow, something profit lore. So last time we ran into a problem where it was RGBA, but the problem with that is that it stores the colors effectively in two forms, 0 to 1 or 0 to 254. And that won't do for us, so we needed to have full floating point precision. We don't need full, but we need floating point precision, including negatives. And you can do that with high definition textures. RGBA-H gives us a half floating point, which is more than enough to incorporate unit vectors, which is what these are. I don't really have a concept of iterating over the files, and I don't want it to be something that we do during gameplay because this is not fast. Like when I release this, all of them are going to be baked in. The only reason we need to do this is when a mod is loaded initially. If it doesn't contain the file, then it'll have to generate it. If it doesn't contain it or the file is not old enough. Oof. Sorry, the file is not new enough. If the movement thing is older, at the same age or older than the map, it needs to be regenerated. Just in case. Well, it would be older than the map, really. If they're the same age, it's okay. Oh. Thinky think. Well, we'll stream of consciousness a bit while I'm doing this. We're creating an image right now that is 6001 by 3001, which is about a 3 by 3 square of screens. That is more than enough for us. We will probably not need that. If necessary, I can cause it to regenerate and make a new one that is bigger. We want to have some sort of limit that says if something is this far away, it doesn't matter anymore. So I figure something like a screen and a half, or I'm sorry, effectively a full screen off of camera or a full screen from center is enough to say this particular enemy doesn't matter anymore, or at least it needs to be moved. We'll see. When the enemy moves to Sector 3, it's not an issue anymore. Related to that, Helldivers is showing more screenshots of the Cyberstan area, and we are seeing images that indicate that the cyborgs are going to show up. Oh, and all of the command transmissions have been hijacked by the automatons in it. It's kind of cool. Like the listing of the major order and whatnot, they're all robots saying you're defective, you're expendable. They're trying to get you killed off kind of stuff. It's a neat touch. So we need two things. Let me plot this out. Where are you, massively butchered paint program? Blank screen, new layer. Okay. It insists on defaulting to a white pad, which is not out of the question, but a lot of programs default to transparent, so you get that nice neutral 2 shades of gray checkerboard, as opposed to the pure white flashbang that this one defaults to. So what we're going to have is we'll have a series of map files out here. And they are in various locations. And what we want to be able to do is for each of them, we want to generate... Molly has found where I put the box. I can hear her scratching away at it. I hear one of the cats wailing on the TV screen. Yeah, I'm talking about you. So regardless of where they are, I need to have both the ability to generate these, but also to keep the linkage between them. As in, I know where they are, or I know what they should be. For the most part, these are just references, and we need to track them differently than we do other textures. And I don't want to have to indicate them explicitly in that regard. But we can. We actually can. Okay, let's... Catalog. All right, so we have... This is what a basic image is, a PNG file. And we're loading textures. But it's going to be... Yes, I know. I know. Primarily what we're caring about. So the actual map image is going to be a PNG. For those that haven't been here for the entire loop-de-loop that has been our how we're going to do maps, we've shifted over to just having fixed images. So this is exactly what it looks like. I may composite them, but for now, an individual room is one image. That is only the visual. The actual floor is a image of the same size, but it has, as far as the opaque region, the area you can walk on. Eventually we'll get like foreground elements and whatnot in there too. But at the moment, it's if you can walk on it, that will be the opaque area. We will take that image, which is like user interpretable, and convert that into something that is meant to be used by the game logic. And that will amount to kind of a negative of the floor image, and the filled in space is going to be wall space with vectors that point you back to the walkable space. That's not perfect. There will be other markers to it, other things that we need to do to make it work for every circumstance. But the first circumstance is for enemy navigation when there are obstacles on the ground, so that they can flow around things like a hole in the ground or similar. Still won't be perfect, but we'll see. Yes, I know. So we need to generate those. So we're going to be looking for... We need a couple of things. We need to be able to differentiate between our map files and just regular images, because it's the map, specifically the map floors. So what we may come up with is essentially a file format name song and dance here. Instead of just .png, it would be something like... We'll use PNG. It's nice and safe here. I don't necessarily want it to have PNG as a suffix. I could do a regular expression, a painful regular expression, to say it is not preceded by floor for it to be PNG. I could also have a not that there are no periods preceding that. Data path. We're checking if it... Because we want to check for... Here, let's... So this is when we call add texture is where we're interested here. Load textures. And we find where we're calling load textures. Interesting. We're double loading these. So we're extracting from all files the files that have PNG, but that gives us image files. Oh no, okay, data extensions. Okay. We're gonna break here. What will this do? One moment here. Break on that. We're going to go to our immediate window. And we are going to say path.getExtension. X.1.2. Okay, it grabs the last one. Do we have... I can name them something different. Like, there's nothing that says I can't treat it as a PNG by when I call it a .floor, but that's troublesome. So what we want to have is the ability to get everything after the first period, which we can do. So what we would end up doing for that is instead of saying the dot extension, we're going to find the first instance of a period. And get everything after that. So it would be like... first occurrence. I could do contains, but that would be messy. We'd have to deal with the order of them. So then if we find, then we can do... data extensions extracts what we need. It's this part is what we're trying to work around here. We need to avoid We could have a repeated one where it's, you know, dot contains a period and then x dot substring x dot find okay, so first file has to contain period and then x is equal to that. Yeah, so we should be able to do an end on these. This will iterate over the whole data folder, and it will find these. Then we can, off of those... Yeah. Yeah. So we're just getting the files here. All right. We don't want this one. We don't want the get extension PNG. We're doing the same, largely the same thing here. So this is going to instead be, let's just double check. Yeah. File dot contains and string starting at file.find period. Equal to floor.png. We will need to upper this kind of scenario. We only care if it is expressly floor.png here. We're going to go to load texture, and from load texture, we jump up to here. Okay. variant. And we're going to jump back up here, actually, and we'll do... of strings. Is equal to new hash set string. Like that, and that, and this. This is, no matter what I put these to, they will be forced to lowercase. This is... Let's go back up, and we're going to have... Molly is getting situated, which means she stands here and makes biscuits for a bit and takes up lots of floor space. Oof. Yeah. Ember sees that Molly got to my lap first and thus does not want to bother. Is this one is image extensions imahe. Okay, back down we go. Another, which is image extensions dot contains. Okay, so it contains a period. It has to have something extension like. Then we're going to say, does this collection of allowed types contain the substring that begins with the index of that period as a lowercase? We will be able to extend that elsewhere. We will be able to extend that repeatedly. Textures are still loaded. Excellent. If I had broken it, I'm sorry, if this didn't work, those images would not appear. So this, the comparable here, when we get to this await load textures, we're going to call into another thing where we get our are not textures, are map floors. It's okay that the actual map image gets pulled in here. That would be expected. This is the meta textures. So again, the floor data and similar. This is so then we need a comparable call here. Let's get slowly get rid of all the magic strings in here. So again, these are files that they're associated with others, and they either need to be generated by the code or they need to be validated when we find them. So the floors are special files. We could break this apart into another function here. Hey, Roman, we are working on our meta file generation. So we got I found a file format that will allow us to do our mapping, essentially. So this is a high def texture representing the unit vectors pointing to the very center of it. So this is 1500 is right there at the center at the convergence of all of these. The black section is all negative numbers, or at least extensively negative numbers. The rest of them have enough color that they can point into the center, but up and left is negative. So it's the bottom right quarter is black visually. So this needs a enumerable string, and then this needs a hash set of strings, extensions. Kitties are doing well. You can see Sammy and Mason napping. Mason has taken Sammy's spot, so she's in the lower left now. Results is equal to that. I can just do this. Oh, thank you for sending a gift sub there, Key Bennett. Contains a period where we find the period, and it is in extensions. So this is extract by extension. And we're going to do all files and meta extensions. Files, image extensions. Then this is data extensions. Refactoring. And this will totally work. It does. Oh, that's not right. That's not right at all. Go. Oh, wow. Mapping of textures. So what we're doing right now is that we're going to actually be creating the boundaries of the maps. Ah, okay. I see where we're failing here. We are mispositioning this. Hey there, Deku. Welcome. Okay, we can still get out of bounds here. Right here. Greater than or equal to 0 and less than 6,000. It's texture yes, I'm going to be using a texture to define where the walls are. Using trickiness. $3,001. And it is greater than negative 3,000. Magic numbers, again, we'll fix that. And else. Right. So because I've got this hard-coded number here, I would have to find every instance of places I'm using that number. One of the problems was up here. Where I'm using these numbers in multiple places. So I should just... And we're going to do height. Then we do upper bound. It's not quite right. We'll need to make sure that they round down here. Is it math f dot floor? No. Wow, that's a mess. Yeah, okay. Well, if we integer math, it should truncate it, so that's still what we want. Lower, upper, height, width. Okay. Lower bound. Not quite right. No, that's correct. That's correct. It's not the... So there's an oddity here. That it's not 1. So because we are reduced like negative half and positive, that gives us so negative 3,000. And if we go all the way up through positive 3,000, we don't have 6,000. We have 6,001. So we need to be cognizant of that. We should also have that. Private constant vector 2. Static. Because it has to calculate it. Let's check. Center is less than or equal to upper bound width. is 3001. But the upper bounds are still correct. This is fiddly. So there are 3,000 on either side of 0 in the width. So the upper and lower bounds are that 3,000, negative 3,000 all the way through positive 3,000. So 1 through, with 0 being the center. So it is... all right, let's... Yeah, we have to do that. Okay, so when we're dealing with the width, it's 0 through 6,000, so 6,001. We want that. When we're dealing with the upper and lower boundaries, those are to the halfway point. The approximate center, or what is effectively the center. Removing the magic, and we're going to move all of this out of this object as well. Quick break, and then we will get to that. Be right back. And we're back. Okay. So this is where the image center is as far as the actual position in the image. So index 3000, index 1500 is with the offset. 0, 0, vector 2.0 is the position once we have accounted for that offset. Or is effectively, but we never really reference it. So we are creating the image with 6001 and 3001. So we get that center pixel. We will fix this in a moment. Yes. Right. We will move this inside of a function here. So the boundaries are inclusive when we're determining where it is. So again, negative 3000 and positive 3000 are in bounds. So 1 through 3000 and negative 1 through negative 3000 are 3000 on each side. And then a 0 to give us 6000 and 3001, you know. Just do a vector 2i. Nope, it won't explicitly convert it, so we'll just do it that way. Expected Boolean is in bounds int x y comma this is mine, and the reason I'm doing it this way is because I'm referencing pixels. The thing that I'm doing I haven't seen before, but it is akin to some stuff I've read. I'm using this to make a kind of a flow map. So each square, each pixel represents a direction to move in. If I am if my offset position from the target that I am moving towards is this coordinate, then this is where I move towards that target, to move to the center. In this case, right now we're using the player as the center, but it could be anything. So that reduces the math down to doing subtraction for an offset, and then doing a reference, get this pixel, reference its x and y. We never do any sort of normalization on the vector. This is useful because that is there may be some GPU calculation going on, but we're going to be doing this constantly. X, Y, Y. So if it's within range, so we're going to say if is in bounds this, because that's more concise and we can reuse it. Okay, then if it's out of bounds, we're going to do something different with it. I'm just filling that in. This is kind of a to-do. We should incorporate this logic elsewhere. Am I going to do stuff, tricky stuff? Yeah, I often refer to this as being clever, and that is simultaneously good and very bad. People try to tell me, "Oh, you're very smart." Imposter syndrome comes into play here, but generally I say, no, I consider myself clever. I am as wrong as frequently as most other folks, but I can come up with novel things. And I can learn. Those two things make an individual very capable and dangerous. Build. Yep. Anybody can make a mistake. One of the markers of skill in that kind of scenario is can you fix it or roll with it? Okay, we're still getting error cases. Oh, let's stop this one as well. I try to fix things. I will often accept a very functional, happy little accident, though. Oh, okay. I forgot. Yes, Bob Ross reference key. I forgot. So I'm spawning these guys out further than the marker would allow them to move. So we are getting incorrect references here. Hello, Molly. So the math isn't right at the moment. How to fix. How many languages do I know how to code in? I have coded in 4 to 5 relatively extensively, but I would need refreshers anytime I pick one up. I know I've done a few more lightly. Like I dabbled in Lua script for doing Noida modding. Of course, you know, HTML and JavaScript, though. Often those hardly count. JavaScript is firmly out of that, is firmly in that, like, oh, it's more of an art than a skill sometimes. Insofar as that, how this very particular browser interacts with this very particular screen element, and did the, you know, the headless chicken fall in the right grid square. Algorithmic horospexy for the win. Okay, we are getting out of bounds. So that is something that we're going to have to address. Let's look at our data folder. In spawn points. Around player. What would it be? Okay, that's... No, that's well within range. Should be. Just for science. That is the scaling value. Horde of things spawn. The offset is not right. And we can see all of the things didn't move here. If I walk down here, I should encounter them. Yeah, you can see them start to appear. So that's not quite right. It's 3 seconds, we spawn 10,000 things. I just have to go in and edit the file to make it not 10,000 things. So the scaling factor is definitely going to become a problem here. General shape seems correct. I'm going to move a little bit to here. Okay, yeah, it's the logic is way off. Because we're getting they're stopping, which means they're in the I am overflowing case or I'm out of bounds case. And they're staying there. Like that there. Oh, it's not it's we need the offset position. Well, that's correct. But this is still way off. So we need to be able to get this aligned. It is important that this align properly. So we need the target's position minus our offset value in order to pull the grid into position. So if the player is sitting at 0, 0, by default, the grid 0, 0 would be right under the player. We are going to subtract our offset. So that gives us that marker here. Now, the entity, our current entity's position, is offset from that. So we add the offset there, which seems correct. So this will be before they spawn. Position is at 14,000. So then our grid position Player shouldn't be there. Oh no, player should be there. Kind of. Room is offset by 96. That door comes in at 96. And then it offsets by 96, so the map is down and right, the door is down and right, so we should have 288. 298 for the target's position. But we're offset further. That is much more. That is 4. Anyway, it's within range of plausible. There's clearly something wrong there, but this 3,000 is more than the screen. Watch how they move. None of them are moving. There's our errors. Lots of errors. Out of bounds. Silly. It is inbounds as far as it's offset, but it is not inbounds because we have added, we have offset its position here. So when we're actually consulting it, Bye. to do it that way. And we're undoing the offset here. Because we're actually querying the pixel here. Ah, such a mess. This is all logic we're going to need to apply soon enough. Not seeing any of them arrive, so similar issue. Currently 92, which is here. If it's in bounds, then adding the, or putting the offset back. Oh. No. We shift it by the image center offset. Some things appear. We haven't slowed to a crawl. But they're also not moving. This is still off. So I need my target position relative to the to me. So from the entity, from the target to us, is the position on the grid. Yeah. Yeah, we have overkilled this. That's it. That's the position on the grid. Because it assumes that, and then we're going to add image center offset. So this would be as if the entity were at 0. Our target were at 0. So the player is at 0 here. So from 0, this is where the target entity is. So if the enemy that's moving towards the player is down and right, it will be a big positive number. We're going to add the image offset in order to make sure that we get a positive number by pushing the effective center of where we're going to go from this position. We're going to push that. Do I subtract it? I should add it. Yes. And we're going to check if it's in bounds. Find out right away. Left side is working. Some of it's working. Okay, let's... All right, so I have our player here. And we have our enemy here. So I create that vector here by subtracting this from that. In the particular case, I'm going to get a positive x and a positive y and a negative x. Then if I add my offset, I'll push it, I need to subtract the offset. Right? No. So then if we have our, let's look at our grid here. So that is our offset. We are going to move it as far as the grid coordinates are concerned. I subtract the height and width to get that. So if the player is sitting at 0, 0, we offset the coordinate space. So we have to add the offset back in afterwards to get the actual pixel position. So this is in offset space, so we add the offset back in. Because that can get us a negative value. We can't have a negative value. We add the offset back in. Should be working. Add it after the out of bounds check. The big hitch you see is creating that many things at once. There we go. Okay. Now, it still costs us a ton to have 10,000 things. So what should be happening here is, yeah, we'll get a distortion as they move in. Extra slow. Okay. Okay. So when we're doing this, what we'll be constantly doing is getting that object, saying, hey, I need the reference to that texture object. Or at least I need the corresponding pixel or vector value. So this service is going to have a lot of stuff that it do. Should clear them out. Technically, they should be dropping by more, but I think I know what's happening is in the first frame, as soon as they exist, they don't have an opportunity to split. But as soon as I move further away, it's possible for them to split. All right. Okay. Think. Okay. All right, now we need to move this logic up into our meta service here. And this one has a lot of predefined behaviors. So when we're loading a floor, we don't actually load the PNG for it. We are loading that as the meta object. We are going to seek a different one, which is going to be our .exr. Which means we'll need to add another extension. Which is fine. Yes. So this is all the logic for generating our default pathfinding, which is just move to the target, period. That's we're calling it move on grid because it's going to translate your world float position into a integer grid position, and operate in that fashion. Okay. So then in our base catalog, it's our meta floor. Huh. Make sure it still runs. I mean, I may have just nuked something. Nope. Ooh, lower invariant. We are concealing what it actually is there. So when we read in a floor file, That's when we want to go after the metafloor. I'm going to put that elsewhere. The file reader isn't looking for that. It's going to say I need a floor object, which is going to be a wrapper around a texture 2D. Well, it's going to be looking for... Okay, it'll find a PNG. And it can find a metafloor, which is... I just noticed that it's... It sounds like I'm saying metaphor. It can find it, but it doesn't necessarily need to load it. If it can't find it, we need to recreate it. But I can just pull the file directly once I've got a floor object. But we're just going to load it as a texture 2D initially. Okay, that'll clean this up further. Breaks down here. We don't need you. Okay, we're loading the textures in. Then we're going to load the data in. And then we'll load the actual catalogables. Okay, so then we need an actual metafloor object. And that is going to take a texture as one of its objects. Loading the texture. And the key is without extension, it adds that in. So we would reference the texture by its non-file extension name to add the floor object. Then when a floor object is created, or at least when its texture is set, we're going to query our meta generation thing and say, either I need one, or you need to find it. Yes. Interface, it's part of this. This is going to give us a texture 2D texture. Bring. Yeah, okay. So this would be a key. This is risky because the naming convention we want to be careful about assuming. And it won't be a PNG. A log. While we're in here, log gets in the file reader, and we're going to go up here, and we're going to say EXR extension, EXR, and we'll put you here. And then back into our meta generator. So it needs a okay. Given a given texture key, it's going to get a metafloor, and the metafloor will have a dot notation at the end before its prefix, so it would still be a dot exr kind of thing. Oh. That even work though? Gonna load it, that'll be fine. We need a way to be able to denote that this is what the object would be. I would like to be able to obfuscate its suffix. Oh, okay, okay. It's going to look for a dot floor. A dot floor is an EXR that we generate from the PNG for the floor. So when we're defining a floor, it's going to extract a particular file name. We're going to look for a file with .floor on it. And if it's contained there, I mean, we can just ignore it and load it manually. kind of a waste to have two different places parse that. Because right now what it would do is it would get the same key. If we were to load it up that way. So I feel like we should skip them and have them manually loaded. All right. Once again, rip that out. So we're going to do pretty much the same thing. We're going to be doing pretty much the same thing as loading textures, but we have very specific files that we're looking for. So we're creating a texture 2D from a file. We're going to get that manually. We're going to look at the key and we're going to say, fetch this texture 2D. We're not putting it into a catalogable, we're getting the texture. So that's the first thing that this is going to do. That's one of them. Actually, it doesn't even need to be an image. It's going to be an image. And if we look at a move on grid currently, we only interact with it as an image. It does not need to be a texture. So the flow to center will be a way to interpret whatever it is. It is not necessarily which changes what this thing is. This is only generating stuff related to room movement. That's okay. No, we'll do that. We're generating objects here. We will let something else deal with them. So if I have this, otherwise generate it. If I have this, otherwise generate it. We want this to happen up front because it's not cheap. But if it happens, we need to trigger like a loading event. Okay. The base objects are, for the most part, the version that I implement. That is, like, base catalog is the catalog that I expect to use in release. But anything else that I write could be for testing purposes. It could be for, well, either testing a new solution or when I totally get around to it eventually and start adding things like unit and regression tests, to allow me to socket in alternatives to allow things like regression or integration tests to work. Unit tests are fiddlier in this kind of environment. Now, I could also have a floor object, which is a catalogable, which would return the corresponding one or the one that's already in it. But this is going to be for when that kind of object gets loaded, it's going to ask for that information. When that value is set, it is going to go look for it. Okay. You right now, or you, or you. Do system.io. Okay, we're looking for that file. If the file exists, we load that file. Manage is equal to null. And we return the image. So this is if the file exists. Otherwise, we make the file. If we get the base texture, then we have the starting point for the image if it doesn't exist. So, but we only need that catalogable, catalog. Services, resolve, catalog. We will already have this texture file, but we need the key to get there. This is fine. If the floor texture does not null. Now we're going to make an image for it. Image is equal to image create. With image.format RGBAH. Come on. Odd. Create empty. That's right. Okay. So this is us making that image. Let's... Okay, we create that. Why is this failing? And the image. Okay, so then we'll need this. These. All right, so what we're going to be doing with this is we're going to iterate over the image, and we're looking for from unfilled space, we are going to look for filled space. And x is 0, x is less than floor width. Equal to 0, y is less than floor height, y increment. So we're going to iterate over the whole image. And we're going to look a distance around that one. And we are searching for that filled space. If we find that filled space, we are going to add the vector towards it. To the vector that we're in, the square that we're in. So we're looking in floor texture here. Image, floor image is equal to texture, floor texture, dot get image. Still get width. That's fine. We're just going to reference only the image here. So this is if pixel x comma y dot a is less than 1. I think the alpha is still going to be 0 to 1. Actually, no, it has to be because we're dealing with a PNG at this point. So we have the floor image and we're looking for that empty space. Now we're going to be looking around it in, we're going to do I and J. Oof. Zero. We'll get to this one in a moment. So we're going to look around it. Then vector to all vector. We don't really need to do that, but it ensures that we're fully descriptive. Say metafloor set pixel x, y. Oh, that's right. Floor x and floor y. Right. At the moment, we're not using the blue channel on it. We are saying that the alpha is 1. There is something here. And then these are the directions to move off of it. It will be the unit sum of all of the vectors pointing to it. So So we're going to start at -5. And we're do the same thing. We're going to look 5 around our target here. Do an inbounds check here. We don't want to limit it. We want to see if it's within range. Okay. And x is less than x bounds. And y is less than y bounds. Inbounds. Plus search y. Okay, so if where we're looking is inbounds, we're going to set that up. Otherwise, we are going to... We do want there to be some sort of marker for it. And what I might do is set it so that if you're outside of the texture, that it points you back towards the spot that you are in. That is, any pixel that is out of bounds adds a to this one to it. That's not perfect because it would freeze things. But for the time being... For the time being, we'll leave it. Okay, so if the one that we have found that is in bounds, if that pixel has an alpha value, that is a valid target for us. So we are going to add the search, the unit of search X in search Y to that. And we're going to add the unit of it so that we don't exaggerate the impact of any one square. Currently, we can decide later to exaggerate that in some fashion if we choose to. But for now. I think that's necessary. Yeah, it's not necessary. So we're going to normalize that and add it in. Then we're going to normalize the whole thing again, and we're going to set the pixel. Now, that should create a file that is kind of a negative of it. So then all the way down at here, we need to write the file. Then we can return it. What are you doing? Oh. Clean that up. This guy had a hairball. He takes it very badly when he has a hairball. So we are going to get that file open again. Move on grid. So we have an image, and we are going to save XVR. It's creating it. We're looking for it. Let's okay. So then if we write it, the floor right Save EXR, texture key plus floor extension. This needs to be in the relevant area though. We would want to get this once we have... We would want to put this with the data file. That's tricky. That's tricky. Okay, we're going to take a quick break, clean up after Sky, and get up and stretch. So be right back and we'll continue. Alrighty. So what we want to be able to do in this is be able to put the files in the relevant location. So just saying, does the file exist, isn't going to help us. This isn't the greatest place for loading those. So we're only going to have the key at this point. All right, catalog. Base catalog. Okay, there we go. So we now have a catalog. We're saying, okay, look for the file. Data path. We know that this is a All right, we're just going to put it in the meta folder here. We'd have to get the catalogable, so this is a protected string. Folder path is equal to log catalog is equal to surfaces dot resolve. So then we're going to try to, if it exists, say meta folder path plus file. Just do the whole thing here. Create that. We're going to do that twice. String. Okay, no, that's fine. That's fine. Get that. We're going to create that, which this is going to be. So we're going to add a string up here. There we go. So then we would need a floor object. Let's actually do a int floor bound is equal to -5. Upper bound. Moving those magic numbers. Clean it up for legibility. We are in the process of formalizing actually creating these. I think having the boundary on the flow to center be in here is actually good. As in... We don't get the image for the flow to center. We get the value of it, and the meta generator has that value. Otherwise, we need to create an object that wraps the flow to center, and I don't think we need that. Same with the meta floor. We'll keep that way. We'll keep that, and then we can always, in the floor object, have a way to translate that. We'll work on that one. This is generally fine, I think, but it still feels like an implementation thing. Yeah. Because we don't, this thing just makes the stuff. That's fine. It is either going to make it and return it, or just return the one that it has. Metafloor will... Metafloor is for during catalog item creation. So this is just during creation. Because the room will have that. That is related to the room. This is related to anything that cares about it. Hey there, Fluff. Welcome. We're working on navigation logic here, which includes wall collision. A lot of the stuff that we're having to do for this is really custom. Well, hello, Hugo, as well. Okay, flows from center is this stuff. Lurking is just fine. To take all of these and mirror them over. Changing the names here so that they are not vague given the various contexts here. But to use this, we need to be able to have the boundaries. If we get the flow map, we have the boundaries. Okay. We set that up previously. It was upper and lower bounds. We are going to want that metadata in there, but it is extractable. Okay, let's put those in here. Lotus Center gives you the dimensions, but it feels like I should just request those. As far as what we used. We'll leave that be. Again, we'll have whoever is consuming this can do whatever they want with Flow to Center. This is just the thing that makes and emits it. New vector 2, which will have width upper bound, height upper bound. Turn the flow image. Okay. It's equal to so then this one is the flow to center path is equal to the meta folder path plus the flow to center, the flow file. is going to be image flow image dot save exr. Using that path. Floor, get flow to center. This one is going to stay here. Yeah. Okay, next we have to try to load it. If file.exists else we create it, and then we ultimately return it. Then move on grid is going to have all of this stuff pulled out. Do not do this. There's our grid position. We can get the data right now. catalog. Oh, I don't need the catalog. It's a service. And this is a universal here. Grid is going to say we'll get the meta generator here, and then flow to center is equal to meta generator dot get flow to center. So now we have that, and we can say okay, we're going to replace all of these. Flow center offset. Nice. We don't care about the height and width anymore, do we? Inbounds. Yeah. Center dot. Width divided by 2. The lower bound is equal to the upper bound times -1. Then we'll do the same thing with the height. Bound on both of them. Just stuff explodes. Lower. Upper, height lower. Okay, we build that. We try to run that. End it. We check our data folder. First, we're going to get rid of test and import there. Okay, we did all of that. Flow image exists. We save it to file, and it should be in data meta flow, but we don't have that, which implies to me that we are getting an error. I think I know what it is. It's that the directory doesn't exist. File can't write. Yep. Okay, so then if I look at my logger, that I just need to find, there it is. Create directory. Base meta generator. Use our meta folder path. Doesn't exist, then we'll make it. Okay. Add a folder, flow file. So then if I go in here, Nice. Effectively the same file. You massive slug of enemies. Run down to here. Okay, we'll see that they're not moving, which means we broke some of the logic. Failed to load image. Okay, that'll cause a problem. Okay, we aren't getting the image. Still not moving, so it doesn't seem like it's the load, like the file format that matters. No, we're actually getting a file. Okay, that's good. It's registering them as out of bounds. Okay, but it shouldn't because those are well within bounds. Should be like 900, 787, yeah. Oh. Do. Had it backwards. I was saying it has to be above the upper bound and below the lower bound of y, and it was within those ranges. So, of course, it would not consider it in bounds. There we go. And here they come. So again, for those that haven't seen this before, there are 10,000 enemies in that ring there. Wonder if we can stop them. We are generating about 3 to the 7th mice which home to a target and bounce off a target on their first hit. So they'll do damage and reflect. There are going to be more blobs, but each mouse can take out 2 blobs at a time. With some wiggle there, because there can be multi-collision. Most of the logic should prevent that, but... So we're slowing down further because we are approaching the entity limit. It is culling them very quickly, but not quickly enough. So the rate of removal dipped, but quite a few of them were removed by the end there. So the homing mice aren't fantastic for that because to get so many of them, we have to spread them out. But that's part of the mechanic of the game, is figuring out which behavioral patterns are going to be the best for your current situation. What is optimal and what is the best we can do right now kind of stuff. All right, so what did we accomplish? We moved our generation of meta files out of this particular movement behavior and into fixed files. So now let's remove the .exr. Again, I want to obfuscate what we're doing here. Because I don't... Ideally, when people are doing mods and whatnot... Okay, no, it didn't like that. Didn't like that. Okay, it depends on the file extension. Oh well. In theory, messing with the flow file would break the game. If I become worried about that, I'll fiddle with it. You'd think there would be a way to force it. Doesn't have any overrides to it. If we got the raw bytes of the file and stuffed it in using that data, we could do that, but we don't have the raw height and width. Well, I'll have to look some of that up. Check something here. Yeah, I think that'll be a good wrap-up point for us. I do need to look at this a little further because, like I said, I kind of want to obfuscate this. Let me check this actually before we get done. It just demands an extension. Well, let's verify that it just demands an extension. There we go. There you go. The operative file is now flow.flow. I appreciate this, though. Like I said, we have 10,000 collidable objects going right now. And we're still getting about 20 frames a second. Visual frames. Physics frames are going slower than that, but the game is still operable in this state. And this is the outer edge. This is, like I've said before, calamity case. Hey, you. Hey, you. Let me check. So right now, there are again 9,000 things, almost 10,000 things standing on the player, which means collision-wise, the system is detecting thousands and thousands of collisions many times a second. And we're still getting it. Like I said, it's slowed down quite a bit, but the way the system is set up, the game will continue to function in the same way despite that. But yeah, this is the basis. What we're doing here is the basis for getting the collision map in place for the rooms. And once we have that in place, combining that with the flow to center with another map that indicates where enemies are, which will be fiddlier. We'll have to pay attention to the performance on that. We'll make it so that we can have enemies and some projectiles that can essentially sort of navigate the room and avoid bumping into each other. The projectiles would not care about bumping into each other or enemies. But we could do that kind of logic and say this is like a heat map of where solid objects and enemies are, kind of stuff. And objects can either home in on things or avoid things. For example, like projectiles that home, instead of saying I will target something and move directly to it, they emit out in a direction, but then they sort of gravitate when they're within range of an enemy, kind of a magnetic effect. If we do it that way, then we can avoid having to constantly look at where that target is. We can still have that kind of homing logic, and we've already coded it. It's that the idea of you almost have like space mines kind of stuff, is you get too close to it and it pursues you kind of thing. That would work for enemies, that would work for the player's bullets, all kinds of fun stuff. But yeah. I think that's a good stopping point. Let's get our wrap up there. Like I said, we made progress. Not as much as I'd hoped because we had to do more debugging, as is normal, as we are wont to do. Anyway, before I get on a tangent, we are going to try to be on schedule this week. Next stream should be on Wednesday, and then we're going to try shoot for Friday and Saturday. Mostly code. I am looking at the pile of games that I might be starting soon. I do intend to try to get one of those. I intend to try to hope to. I want to start one of those this week. So we've got a pile of investigative games, which are lots of fun. At least for me. I hope everybody enjoys watching along. If there are other things that you think would be a good fit for the channel, the Discord server has a suggestion box for words and things. Has a suggestion box board where you can drop links to games and the like. Like I said, it needs to be a good fit for the channel, so there are a lot of popular titles going around lately that aren't going to happen. But I'm always interested to see what kind of suggestions people have. Now, with that said, I hope everybody had a good time watching with us today. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those things down there are generally good, so press those buttons. If you'd like to consider financially supporting the channel, you can do so through platform-specific means as well as other options available through the link tree in my video descriptions and bio. But with that said, I hope the rest of your day is good, and I will see you next time.